in our MATLAB workshop. So we will be talking about fuzzy logic using MATLAB. First of all, we need to define fuzzy logic. Have you ever heard with fuzzy logic? Anybody here before about fuzzy logic? Fuzzy logic, can you hear me? صوتي مسموع يا شباب؟
Yes, doctor.
Okay, very good. So fuzzy logic is a kind of logic. It's called, or it is type of MVL, or multi-valued logic. Okay, simply fuzzy logic accepts partial truth. So it accepts partial truth or truths, and it mimics how a human brain works. Okay, أنا بضيع هون. Okay, so it accepts partial truths and it mimics how human brain works. شو معنى هذا الكلام, or what does this mean? Now, if I have a group of people like you, I have 16 people, for example, and I need to classify them by age. Okay, so I can classify them based on age groups of, let's say, 18 to, let's say, 25, and 25 to 35, and 35 and above. So I can say that these people are, let's say, young, and these people are, let me call these people very young. These people are young, and these people are old. Okay, now if you think about this, you are giving this kind of people who are, or this age period from 18 to 25 a certain description based on your application. However, do you think it is appropriate to say that someone at, let's say, someone at 34? So if you discuss someone at 34, someone at 34 will be at the end of the period of young. Okay, so is it appropriate to call him young while he is at the end of this period and very close to this period? What about people at, let's say, 34.9, or let's say based on age? So 34.9 means that he is like 34 years and almost 11 months. So he's still young. Now, after 1 month, he will be old. So this is the argument for defining the fuzzy logic the way it is. Another example, if you need to classify them by their height. So you can give them, for example, from 120 to 150, these people are short. From 150 to 165, these people are medium, for example, and from 165 up to 185, these people are tall. The same applies here. You have something called crisp boundaries. You have crisp boundaries. Okay, and crisp boundaries means that if this is your age line, okay, this is the 18, 25, 35. So this means that these people are very young, these people are young, and these people are old. Okay, this boundary is called a crisp boundary. So it starts here. The boundary for the young starts here, and for the very old people it starts here. Fuzzy logic does not think in the same manner. Fuzzy logic, it does not define, or it does not define any kind of crisp boundaries. Boundaries in the fuzzy logic are changing, or they are, let's say, fuzzy. They are vague. Which means that, let me give you a simple example. I can define colors from white to, let's say, black. So if I have seen this color, I can call it white. Correct? And this color inside, I can call it black. However, between white and black, this is called the Boolean logic. So if you define colors as white or black, this is called Boolean logic. You are assigning a certain value, x equals to 1, for example, for white, and x equals to 0 for black. Something like this. However, don't forget that there is a long range between white and black of, for example, this can be, for example, white. This can be at the middle, you can have gray, for example. So here you can have like extremely white or extremely white, or you can say that this is the extremely white. This is very white. This is, for example, cream. Okay, here you have gray, for example. Here you have extremely black, very black, وهكذا. And this is how a human thinks in general. You accept partial truth. So if white is truth and black is truth, you can accept all the spectrum between them, which is partial truths. Okay, so if you go back and check about the ages, people at 24 are still considered very young, and people at, let's say, 26 are still considered young. However, people at 24, they have properties of very young and they have properties of young, yet they are considered very young. Okay, so what fuzzy logic do, it for example, if you think about people at at 24, they can be said to be in the very young period. However, they exhibit properties of people at young. So I can define them as having very young properties and young properties at the same time. How can we do this? We can do this by creating something called membership function. So I can say, for example, instead of this representation, instead of this Boolean representation, I can say, for example, that people at 25, okay, so if this is 25 and this is 18, So people at 25, this is the end of this period. So these are very young people. Okay, while people at, let's say here, okay, people at 25 and above are young people. Okay, so at 25 I can start and I can end at, for example, 35. Okay, now people above 35 can still be considered old. So these are the people at 35. Okay, now let's connect this line, and don't forget that this is 35, this is 25, so the average will be 30. Okay, أو خلينا نحطها هون. Okay, so based on my definition now, these are young people and these are the old people. If you look at this definition, you will see that the very young starts from 18 and goes to 25. However, it extends in a certain method or way up to 30. Now, people at 25 can be considered, or above 25 can be considered as young. You go up to a certain, let's say, age, then you go back to 35. Now, this definition is good, or truly describes people between 25 and 30, and people that were already considered as young, and they exhibit properties in both very young and young. So if you go for someone at 27, if you go upwards, something like this, someone at 27 is having this much of youngness and this much of very youngness. Okay, while, for example, people at 32 can have this much of old properties and this much of young properties. واضح? Let me put this at 1 or 100%, for example, 100%. So when someone at 32 years old can have, for example, this can be like a certain percentage, something like 35% in oldness, and something like, for example, 85% in youngness. واضح? Is that clear? So at the same time, at the same age, you were able to define the same value of age under two properties, or under two, let's say, periods. This is what we always we always use in our daily life. So we can say that someone is young, but he's still or someone is old, I mean, or someone is very old, but he's still at the beginning of the period of old. So I cannot describe him to be 100% old. He may be 10% or 20% old and 80% young. Okay, so these terms, very young and old, are called linguistic terms. Okay, so this is the idea behind the fuzzy logic. Now, in other words, fuzzy logic, as we said, accepts the partial truths. Partial truth is the periods that are within inside the same period. So if you look at the Boolean logic, it is a crisp period, well defined. However, the period or the boundaries between this period and this period are fuzzy or vague. Okay, it can be called as fuzzy or vague boundary. Okay, so there is some little history about fuzzy logic. It was first defined or used by someone called Lotfi Zadeh in 1965. He published a paper, I think its name is Fuzzy Sets, and he defined all of this. Then, after a little time, maybe up to something like 100, up to 80s, I think, 180. Okay, this logic was used to control the first industrial cement kiln. Okay, cement kiln means that it is the furnace used in the cement factories. Then it was a long period of Japanese, let's say, technologies who invaded the world, as you know, with their washing machine, with their TVs. So if you go and check your washing machine, if you check your washing machine, most of them are having fuzzy logic controllers. Okay, if you check your dryer, washing dryer, it may have a fuzzy logic controller. Your car ABS, it has a fuzzy logic controller, or at a certain, let's say, period of time, it used to have a fuzzy logic controller. So fuzzy logic has many applications in technologies, in electronics, in car systems, and many others. Okay, so this is an introduction about fuzzy logic. So, but as a student now, or as a person, why do we need fuzzy logic? So today we will have two examples. One example about, it will be very simple. So it will be about restaurant tip, and one example will be about 1 minute. Okay, we will make an example. I will think about something. Actually, I thought about something and I prepared it, but I forget about it. So during this session, before we go here, I will remember. So let me tell you something. Now, in order to make the fuzzy logic, and this is what we will do today, the steps are as follows. First of all, we have to make something called fuzzification. And fuzzification is simply making or designing the membership function. Or MF. This is the membership function. For age, for example, this is our membership function. For example, so it is something that some kind of your variable, let's say age, and you define your variable in a fuzzy way, okay, where the boundaries are not crisp and boundaries are vague. Okay, the second step is the fuzzy inference system. Okay, I will not explain this because this is very advanced, but usually we have two types of fuzzy inference system. One type, or the first one, is Mamdani, and the second one is, I think, Sugino. So the fuzzy inference system, think about it as the box where all the variables, input variables, go through. Okay. Now, the third step is to define something called fuzzy rules. Okay, I will go through them one by one, inshallah. Then we will have the defuzzification. Defuzzification means that you take a value, then you convert this value into crisp value, or getting the output from the system. So if you need to make it like a flow chart, it will be something like this. This is variable 1, for example, variable 2. We make fuzzification. So this is fuzzification. They go into the fuzzy inference system. Okay, you add the fuzzy rules. Okay, then there will be the defuzzification process to get the crisp output. This is your output, but you have to go through all these processes. It's not that hard. Maybe the names reflect that it may be hard or complicated, but it is not complicated though. طيب. So let me tell you about your washing machine. Fuzzy controller. Okay, your washing machine fuzzy controller. First of all, most washing machines are having fuzzy controllers, but how does it work? Now, usually it's used to control the spin duration or the cycle duration. It also controls the spin speed. Okay. It also can control the rinse speed as well. Okay, so this is the output. This can be, you may have more than one output. So this is the fuzzy logic system. And your variables are usually the mass of the laundry or the volume, but usually it's measured in the in types in mass. Maybe the temperature. Also, the type of dirt. Each type of dirt is different, so it may need different cycle properties. Also, you can also, or some of them are also having the dirtiness of laundry. So depending on these variables, it can go into the fuzzy system. So, but we need the rules. Rules are simply connecting words. Rules are connecting words or connecting that connect input to output. usually used to infer. We use the term infer input to output. So for my washing cycle or for my washing machine, I can write a certain rule to be. This is the general form of the rules. F, okay. I have 1, 2, 3, 4 input variables, so I have to take them all into the rules design or definition. So I can say if the mass, أو بلاش if mass is, for example, high, and this is and temperature is, I started with a complex system, I can start with a simple system. However, I can say if mass is high and temperature is high, for example, and type of dirt is, for example, grease. طبعا this is all depending on the membership functions that you are using here. Okay, and dirtiness is, you can say that it is high, for example, then cycle duration is high, spin speed is high, and rinse speed is high. So simply a rule in this form. If you have, for example, two variables only and one variable for the output, you can say that if variable 1 is or is not, okay, high أو بلاش high, low, medium, high, and variable 2 is or is not low, medium, high. This is the general form. Then output is not low, medium, high. Okay, but usually you don't have only one rule. You have a set of rules to make sure that you are addressing all the possible possibilities or all the possible probabilities for your system operation. So for example, if you have a variable 1 with low, medium, and high, and you have variable 2 with low, medium, and high. So this means that your number of probabilities is, let's define them in this way. Variable 1 can be low, okay. Variable 1 can be medium and can be high. Okay. However, variable 2 can be, I will put this in blue, can be low, medium, and high. Correct? For medium, so for low, variable 1, variable 2 can be low, medium, and high. Now for medium variable 1, variable 2 can be also low, medium, and high. And this is the same with. So if you count these, it will be 3 multiplied by 3, which is 9. So you need 9 rules, depending on the membership function design and how many subset it has. Okay, so if you add variable 3 with 3 subsets, so the total number of rules required are 3 cubed, which is 27. Okay, I think I know that it may be new to you, some or this kind of logic may be new to you, and it may seem a little bit complicated. and you may not understand some of these principles. However, once we go now and do our first example, you feel that it is very simple. طيب, so far, do you have any problem? Guys, I will look into the chat. Tell me, do you feel it's hard? Do you feel there is something missing? Did you understand the basic idea behind the fuzzy logic? I can't see any messages. Okay. So, يعني, we have another message. Latifa, yes. Okay. طيب يا Latifa. So let's have one simple example. And this example actually is well used in the MATLAB website. Okay, they always give you this example as beginners. So you went for a restaurant. Okay, and you had food, lunch, for example. And you need to give a tip. However, you need to give the tip in such a scientific method. Okay, not arbitrary. So you need to give the tip based on food and service. Okay. Now note, food quality, for example, cannot be defined in a number. Service as well are uncountable, cannot be defined as a number as well. Okay. Tip can be defined as a number, but you need your tip to be based on the food quality and service. Okay, so simply, this is a fuzzy logic system where you have food quality as your first variable, and you have service as your second variable, and your output is the tip. Okay, this is the fuzzy inference system. So now you need to add the rules. If you go and check our steps, the first step is to define the variables in a fuzzy form, or to defuzzify the variable. Oh, sorry, to fuzzify. So I can say that food quality can be defined in this membership function. For example, food quality can be defined in this membership function. So if the food I will call this excellent quality. I will call this, for example, medium quality. And I will call this low quality. Okay, so low quality, if you feel that if you give the food like 3 out of 10, so it may be something like 30%. Medium, something like 50%. And excellent, something like 90% or 80%, let's say. Let's call it, instead of excellent, let's go call it delicious. Okay, and low, you can call it non-delicious or not delicious. You can call this good, whatever you like. So this is the food quality. Okay, now What about the service? You can do the same, or you can do a new membership function. So up to, for example, 20%, here from 20% to 85% and whatever. So this can be, for example, 20%, this can be 50%, this can be 80%. خلي high 70%, whatever you like. Now, so this can be service, bad service, medium service, and good service. Type. So now you have your input variables fuzzified. Now you need to fuzzify the output. Now your maximum tip can be, for example, $20. Your lowest tip can be, for example, $5. So this is 5. Your median tip can be 10, let's say. So this is $10 and this is $20. Okay. So I will call this low tip or small tip. This is medium tip and this is large tip. Okay. Type. Now, if you think about it, if you have quality, food quality low, okay, and the service is bad, you will definitely give a low tip, correct? Correct? But if you have at the same time the food quality was high or good, or service was good as well, you will definitely give a large tip. Correct? So I have already two rules defined. The first rule can be in the form, if food quality was low and service was bad, then the tip is low. Okay? There is no problem with these two rules. However, you will have a problem with a rule that says, for example, if the food quality was high, okay, and the service was bad. So do you give a tip or not? You should, yani, you are giving a tip in all ways. In either ways, you are giving a tip. However, your tip will be large, medium, or low. Okay, considering that your tip will be large if the food quality is high and the service is good. What about if you have low food quality, but you have, let me put this here, low food quality, but the service was good or excellent? What tip should you should give? This is what you always, it's not necessarily a Salim. It's not necessarily. Okay, you need to get, you may give a medium tip, but medium starts from here and ends here. So what is the actual amount of tip you're going to give? So you need the program or you need the logic to define the actual amount of tip you need to give. It's not only about medium, you need to defuzzify as well. Okay, so usually this can be done by an expert. Usually fuzzy rules are usually done by an expert. You need experience to make the fuzzy rules. One simple method is to give, and this was used by someone, I can't remember his name, but one simple method is to give this membership function subset a certain weight. So this can have a weight of 1, this can have a weight of 2, and this can have a weight of 3. This is called, I think this method is called weight, average weight, something like this. And this one has a weight of 1, 2, and 3. So it depends on the programmer. So you can have the food quality to have higher weight than the service, and you can have the service to have a higher quality than the food. But in our example now, we will consider that both of them are having the same weight, and each one of these subsets have a certain weight, and they have all the same weight. So you can, once you finish, give them weights. So this can be 1, this can be 1, and if the average, since you have and here you will have and. Since you have and, so you can add them together. So your total weight will be 2 out of the maximum weight. Maximum weight is the best case scenario where this weight is 3 and this weight is 3. So you can define them as the maximum weight. So this can be 0.3, for example. Then you can define crisp boundaries. Okay, then you can define crisp boundaries. If your average weight is, for example, less than 0.4, the tip can be low. If the average weight between 0.4 to 0.8 مثلا, tip can be medium. And if your average weight is larger than 0.8, tip can be large. This is one method. Okay, and there is no actual method of defining the weight, but it's all experimental. Let's say it's all people are trying hard to get the best method to define the weights. However, it still need experience. So we can do something like this. We can give some kind of rules. So I don't have the rules ready, but we will write them once we start the program. Okay. Type. So once we finish, we can get a 3D view or a 3D graph. Okay, it can be in the form of a surface, for example, something like this. Okay, and this, for example, can be the service, and this can be the food. So you go and check what is the actual number of tip that you are going to give for the waiter. So let's start with this example. Okay. Now I will start the MATLAB. From the store. So give me 1 minute to start the MATLAB. Okay, 1 minute, please. Okay, so I will start sharing now from MATLAB. Can you see my MATLAB screen?
Yes, Doctor.
Okay, so if you need to start the Fuzzy Logic toolbox, you can just type fuzzy on the workspace. Tamam? Can you see now my Fuzzy Logic designer? Can you see my fuzzy logic designer? What can you see? Can you see my fuzzy logic designer? Okay, 3 boxes. Okay, so this is the input, this is the fuzzy inference system, and this is the output. Tamam. So we have 2 inputs. So we can go and file, add variable, add variable, edit add variable input. So we said that the first one will be food quality. Okay. And the second one, طبعا here, and the second one is the service. We'll call this food عشان ما يصير عندي هاي المشكلة تبعت food طيب, and the output is the tip. So my output is the tip amount. Okay, now we need to go and define the membership function for the first variable, which is the food quality. Okay, طيب, so if you look here, it was defined by default as MF1, MF2, MF3. So you can select, first of all, you need to select the range. So you go and select a range from 0 up to 100. So let's deal with percentage. Okay. Now let's go for MF1 and define it as. Now here you have different types of membership functions. Membership function can be triangular membership function. This is the triangle membership function, and this one is the triangular membership function. It can be trapezoidal. So this is trapezoidal membership function. It can be as well many types. All these are types of membership functions. Each one has a certain application. So you can get, for example, the bell. This is a bell membership function. This is Gaussian. You can select any one of them and you will see that it is different than the. Okay. For me, I will select the MF1, which is the food quality is low. Low food quality. I will make it as a trapezoidal, and I will use the same numbers that we have discussed. So for the parameters, you can drag it from here. Okay, you can drag it from here. You can drag this point or this node as well from here. So I will put this at 50 and I will put this at 30. Okay. However, once you have experience, you can make it exact from here. You go to parameter here and you can make it exact. So I've been doing this for a long time, so I can say that it is use this window. But for you, you can define it by dragging these nodes. Okay, MF2 is the food quality medium. So I will call it medium. Okay, and I will give it a range from 30, 50, 80. بلاش 80 خلي هاي 70. طبعا it depends on you. It depends on the user. And this one will be a good quality food or excellent quality. I would call it good quality food. It will be also triangle, trapezoidal, and it will start from 50, goes to 70, then it goes to 100. Or it goes to بلاش خليها from 50 to 70 to 90, then 100. This can be 100. Okay, but for you, you can use this and you can input here, or you can drag it from these nodes. It's up to you. Okay, so we have already defined the food quality membership function. We will do the same with the service membership function. So first of all, let me define the range from 0 to 100. MF1 will be bad service. Okay, it will be trapezoidal, and it will have a range from 20 up to 40 or 50, خليها 50 up to 50. Okay, so this is the bad service membership function subset. The medium, أو خلينا نحكي good service بلاش medium, it can start from 20, goes to 50, and ends at 80. While the excellent membership function, this is excellent, it's not a membership function, it's a subset. It can be a trapezoidal, and it can start from 50, goes to 80, then 100, 100. So I have already defined my membership functions. Now, if you are following up with me and using MATLAB, you can define them in a different way. You can define them in the different ways, so we can have an idea about what is the effect of the membership function on the output. طيب. So how about the output, which is the tip? So we said that your maximum tip can be $20. Okay. So your maximum tip can be 20. So for the range, we can go up to 20. See, 20 is your maximum now, and 0 is your minimum. Type. Now, let's go and define the membership function for the tip. The first one can be trapezoidal. This can be low tip. Low tip can be from 0 up to $5. So I can go to here. I can write minus 1, 2, 5. So yes. طيب. And the medium tip, can start from 2, okay, can start from 2, can go up to 10, بلاش 10, 8 for example. ماشي خليها 10. Then it can go up to, let's say, 18. Okay, very good. So this is the medium tip. What about actually, let me connect this to 10. Or let me make this -1, 5, and 10. This is better. And this one can be 5 up to 10, up to 15, for example. So this is the medium membership function. And the high tip can be above 15, so I can say I'll make it trapezoidal. So this can be like starting from 10, goes up to 15, then goes to 20. This is 15. Okay, and we will call it large step. Large step. Okay. Now we have defined the membership functions for the input and the output. Okay, شباب معانا? Are you following up with me? طيب, so let me close this now. Then I will go to the okay. So now I will go to the fuzzy inference system. Double click here. Now you will have the rules. We need to enter the rules. We said that the number of rules will be equal to the number of probabilities or possibilities. So we know that food quality can be low, medium, and high, and service can be also low, medium, and high. Okay, so I have 3 and 3 possibilities, 3 multiplied by 3, so you will have 9 rules. Let's start by food quality low, service is bad, then the tip is low, so you can add this rule. Okay, now for the second rule, my food quality can be medium, my service can be, or خلي high low, خلي high low. Your food quality can be low, your service can be good. However, your tip is still low, so you can add this rule as well. Now, your food quality can be low, your service can be excellent, and your tip will get up to medium, for example. Okay? So I have 3 rules now. Let's go for the medium and go back to bad. If your food quality is medium and service is bad, your tip will be low. While good and medium and good can be medium. And medium and excellent can be, for example, medium or large. طبعا depending on your choice and experience sometimes. So this can be, for example, medium and excellent can be still medium. Okay, so now let's talk about the third option, good and bad. It can be low. Good and good. Good and good here. It can be medium. Good and excellent is the only option for large, for example. So I have 9 rules now. I can close the rule editor. Okay, so now our model is finished. We go for view. Let's go first to the surface, then we will go back to the rules. This is my surface. Okay. This is my food quality and this is the service. Okay. Now, if you have a certain food quality at 50% and service at 50%, then this is your tip, can be here. So you give, for example, $14. Okay. You can change this to be, yes, you have 2 options actually. But you can, yes. Maybe this one is better. This is the usual presentation of the fuzzy logic systems. A 3D surface. It gives you the food quality and give you the service on the X and Y axis, and the Z axis can give you the tip. Okay, let me close this and go to the view rules. Here at this window, you can input the numbers or the options here. You can select the food quality to be, for example, 80%, the service to be 80%, and your tip will be $16. واضح? This is called the defuzzification of the tip. This is the defuzzification of the tip. Now, if we went back and went for the rules and we change, for example, this rule, good, good, it will be large, for example, and close, you will see that your surface will be different. Okay, your surface will be different. This is service and this is food quality and service. Okay, so this surface means if you go and check 0 and 0 or 20 and 20, you are in the $4 range. While if you are at 100 and 100, you are in this range, which is almost 16. واضح? If you go for the rules here and you select this to the max and select this to the max, so your maximum tip can be $16, while your lowest tip can be, in the worst case scenario, can be $3.84. Okay, if you didn't like the food and you didn't like the service and yet you need to give a tip, your tip will be $3.84. واضح هذا is it clear, this model or this presentation, this fuzzy logic model? لا يا سالم, you cannot make the rule as you like. As I told you, now if you make rules as you like, sometimes you will have a problem. Let me show you what may happen. So if you don't make a rule based on a certain criteria, let me make this as large. Okay, the first one, which is where the food quality is low and service is bad, let me add this rule to be large, something like this. If you go and check the editor now, if you go and check here, okay, it will not give you a good forecasting for the tip, let's say, because if the food quality is low and service is low, you are giving a tip of $10, which is in the medium range. Let me show you the surface. What happens to the surface now? You will see that the surface is not as you think. Okay, so you are giving a higher tip for lower service and food quality, and you are giving lower tip for medium. So this is why rules. Okay, so if you prefer food quality more than the service, this means that you are giving more weight for the food quality. So let's go and do what Salem says. Okay, let me go back to the rules. Now Salem, he's an expert and he prefers food quality more than the service. Okay, so he's more sensitive to the food quality. So if the food quality is low, okay, I will delete all the rules. Okay, and let's define this based on Salem attitude. So if the food quality is low and the service is whatever service means that you select none, then the tip is low. Okay, so you can add this rule. You can add this rule. Now, if the food quality is low and the service is bad, you will also give a low tip. If the food quality is still low and the service is good, you will also give a low tip. Also, if the service is excellent, you will get a low tip. So you can add these rules. Now, once the food quality becomes medium and the service is bad, you don't care about the service, so you can give medium tip. Also, if it is good, you can give a medium. Okay. Once the service gets excellent, you can give a large tip, for example. Okay, or you can give a medium here as well. Now, if the food quality is good or tip is service is bad, you can give a medium. Now, good and good, you can give, for example, large. And good and excellent, you can give large. Okay, so now we have 10 rules because this one has like none, okay, or any. Yes, you have to write at least all the probabilities. So let's go now and check our surface. So this is our surface. Okay, if you look at this surface, you will see that Salim will not give any tip if the food quality is low, regardless of the service. Okay, so if your service is great at 100% and your food quality is at 10%, you will give a $4 tip or a low tip. Okay, however, once your food quality start being good or start being enhanced, you will start giving a tip. This is why I am telling you, for the rules, you have to be careful. Okay, so let's do this here. Food quality is bad. Okay, service, it's not sensitive to the surface now. Okay, however, if you go beyond this point and say that your food quality is medium and the service is 100% good, your tip can be 16. Maybe if you increase this, it is still not increasing. So whatever your service is, you cannot exceed 16.2, for example. طبعا you can play with the rules as long as they are conforming. يعني أهم شيء, the most important thing is you don't give contradicting rules. Okay, contradicting rules will not give you a good surface like this. You will have up and downs here. Okay, so you can do the same if you prefer the service or you are giving more weight for the service than the food. Okay, but if you have let's say the same weight for both of them, you can treat them in that way. So once you start and have more examples and work more and more, you will figure out how to deal with rules in a better way. Okay, but as a beginner, يعني, pay attention for the rules so you are not giving contradicting rules. This is the most important thing. Okay, واضح شباب؟ So you can yes, so you can use you can model any system you like based on this. So for example, you are trying to sell your car and you need to find let's say or you are trying to actually buy a car, let's say, and you need to put a price for the car or price the car based on the age of the car, based on the status of the car, based on the kilometers or mileage of the car. So you can do this. You may have some simple applications for this. Now, if you are talking about the control, usually the control, if you are trying to control something, if you are trying to control a robot or trying to control a certain system, or trying to control, for example, let's say a factory, industry line, let's say, usually the rules are well defined. So if you have action or variable 1 at certain location and variable 2 at certain location or values, then the output is well defined. You need to make a certain action. Okay, so in control, we don't use, or we don't try to use the Mamdani. It's better to use the Sogino membership function. So you can change it from here. Yes, so it's better to use the Sogino membership function, not the Mamdani. Mamdani is good for modeling, forecasting, risk assessment. Sogino is better for control, okay, fuzzy control or fuzzy controllers. Okay, so this is a very simple example to show you how can we use a membership function. Now, we can add, for example, another input variable. So edit, input variable. Okay, I can call it whatever you like. For example, food quality service. You can call it, for example, atmosphere. Here, atmosphere inside the restaurant, and you can put rules for this variable as well and get the tip values. Also, you can add variables for the output. So what do you mean by output? For example, it's not only the tip. Also, for example, at time, you can say I need to spend, for example, 10 minutes in this restaurant or 20 minutes. So it is the time for spending or the time after the lunch or after the food, the time for spend time after the lunch, for example. Whatever. We are just saying that you can have multiple inputs and multiple outputs as well. Okay, and the form of the rules will be changed as well. So your rules now, the first variable you can select, the second variable, the third variable, and this is your output 1 and output 2. Note that you have also options for not here. If the food quality is not good, for example, or if the service is not excellent, then the atmosphere is not, or the atmosphere is not MF3, مثلا, then your tip is not large. So you can use this. You can also change the connection between the rules. If the food quality is low, or you can use or here, the service is bad, then your tip is low. Whatever, each one of them is low or bad, that your tip will be low. So the rules writing, it needs some cautious. You have to be cautious and you have to think of the rules, not to give contradicting rules, and make sure that the rules describe the actual case. Okay, now for example, I will show you something. I will open one file for you. Okay, this is my this is a part of my research. So I will show you. Okay, file. I will show you one model that I have did before. Okay, I will show you one file that I have done before. Okay, I cannot go to the Dropbox. I will take it from here. I think it's a backup. Okay. Okay, so this is one file that I have done in the past during my studies. Okay, let me show you the rules. Let me show you first the membership functions. So this is one membership function, and this is my output. So I have like, okay, let me show you how many rules I have in this. Let me show you how many rules I have in this model. So I have almost 1000 rules. All these are rules. Okay, so I have 972 rules. Okay, يعني it can get very complicated sometimes. So this is, for example, part of my results. Okay, now once you get to be expert, there is another way of entering the rules for the fuzzy logic system. You can do it in, for example, Excel file, and you can import it in a certain way. Okay, so I have 972 rules because I have 1, 2, 3, 4, 5, 6 input parameters. Okay, one of them is having 4 subsets. So this one is having 1, 2, 3, 4 subsets. So this is 3 multiplied by 4, 12. Multiplied by 3, multiplied by 3, multiplied by 3, multiplied by 3. So if you multiply 1, 2, 3, 4, 5, 6. So if you have 3 to the power 5, 3 to the power 5 means like it is 81 multiplied by 81 multiplied by 3. Then you multiply by 4, it will be 972 rules. Okay, to have all the probabilities in the system. So sometimes it gets very hard. Especially if you have plenty of input variables and each one has many subsets. So it can be very, very tough. However, for examples like these, it may be easier. And actually you can do this. I will close this. To make it easier for you, sometimes when you add more variables, you can make them as 2 subsets. Okay, you can make them as 2 subsets. So you can make the low and medium interfere with low and good, for example, interfere with each other to define the medium state. So if you are not that sensitive, or if your system is not that sensitive, so you can make this at 30, then 80. And this one can start from 30, 50, and 80, 100. أو بلاش 30, 50, 100, 100. Okay, أو 30 80 خلينا نسويها. Okay, so the medium subset can be defined. However, you need more knowledge or expert to know how to define the medium state without putting the subset. Okay. So here you can play with the rules in order to make sure that you take the medium subset into consideration. So now you have 2, 2, 2, you will have 8 rules, but it will not be that efficient. It will be good, but it will not be that efficient system. Okay. Fine. So I think one example is enough. We don't need to repeat ourselves in the next example. The most important thing is to know how to make the fuzzification or creating the membership function for the input variables and output variables as well, and also to provide proper rules that fully describes your system and all the probabilities that you are doing. طيب. So I hope this was useful for you as an introduction for the fuzzy logic system using MATLAB. Actually, it's a toolbox for MATLAB, and fuzzy logic system can still be done using many other softwares. There is some dedicated softwares for fuzzy logic modeling. It's not only MATLAB. There is some dedicated softwares. There is also R language. If you know the R language, it is also used in the fuzzy logic modeling. طيب, so I think that's enough. If you have any questions, I will be glad to answer you. If you are